Welcome to this guide on aviation meteorology and understanding Earth's atmosphere. We're going to explore how the atmosphere surrounds our planet and why it's so important for pilots and aviation professionals. By grasping these basics, we can better appreciate how atmospheric conditions affect flight safety. Think of Earth's atmosphere as a protective blanket made mostly of gases. It shields us from harmful solar radiation and plays a big role in shaping weather patterns. For anyone involved in aviation, knowing how this blanket works is essential because it directly impacts how aircraft perform and how flights are planned. Dry air is mostly nitrogen and oxygen, making up about 99% of its volume. Nitrogen is the largest part, followed by oxygen. Though smaller in amount, gases like argon and carbon dioxide also play important roles. These trace gases influence weather and climate, which pilots need to understand for safe and efficient flying. Even though trace gases make up a tiny portion of the atmosphere, they have a big impact. Gases like neon, ozone, and methane influence weather and climate patterns. Water vapor, which is always present up to about 4%, is especially important because it affects humidity and weather conditions that pilots must consider. The atmosphere isn't just one uniform layer. It's made up of several distinct layers separated by transition zones called pauses. Each layer has unique properties that affect aviation differently. Recognizing these layers helps us understand where weather happens and how atmospheric conditions change with altitude. The troposphere is the lowest layer where all weather relevant to aviation occurs. It extends up to about 10 kilometers near the poles and up to 18 kilometers near the equator. Temperature generally drops about 6.5 degrees Celsius per kilometer here, and pressure decreases with altitude. Knowing this helps pilots anticipate weather changes and plan flights safely. Above the troposphere lies the tropopause, a boundary where temperature stops decreasing with height. It varies by region, lower and warmer near the poles, higher near the equator. This layer is important because it often hosts the jet stream and clear air turbulence, which can affect flight routes and safety. The stratosphere extends from the tropopause up to around 50 kilometers and is known for stable air conditions, free from weather disturbances. This layer contains the ozone layer, especially dense between 20 and 25 kilometers, which absorbs harmful ultraviolet radiation. For aviation, this means smoother flying conditions above the weather. Just above the stratosphere is the mesosphere, reaching up to about 85 kilometers. It's the coldest atmospheric layer, with temperatures dropping to nearly minus 90 degrees Celsius. This extreme cold affects atmospheric phenomena but is beyond typical flight altitudes, though it's important for understanding the full atmospheric profile. Finally, the thermosphere is the outermost atmospheric layer, gradually fading into space. Despite very high temperatures caused by solar radiation absorption, its low density means it wouldn't feel warm to us. This layer hosts the International Space Station and is where auroras occur, marking the boundary between our atmosphere and outer space.